previous session. So yesterday I was going through our book because we have covered our topics at a different order. So as we discussed that we would basically want to, towards the end of this particular book club or this book chapter, right? We're to kind of finish to kind of look at the example of what we have in the book, right? And while going over the things stuff, I realized that, or as I was going through that, we need to kind of think about how we can build a data pipeline, all right? And for the data pipeline, what are things we can do on top of Kubernetes? And that's where I came across a Spark and Airflow both. I tried it earlier as kind of skimmed through the book, but yesterday I thought, okay, let me try to do some hands-on and then try it out there. So Uh, so yeah, that's where I kind of, to be honest, yesterday I thought of taking a look into the Spark and Airflow in a bit more detail, and I spent some time yesterday and today. But to be honest, I could not really have the demo working. Though I tried few things, but I got stuck to a problem, and that is where I am in right now. But being said that, we still kind of try to in the session, we still try to kind of get where this book is going and how we can come back and finish the eventually last example what they have to kind of close this book officially and then move on to the next book in couple of sessions, right? Um, so far the story the short story is that what we have learned in our book club sessions, right? We looked at a high level what is AI, what is machine learning, what is deep learning at a very high level. Then we talked about how we can how the machine learning in general works, right? So we saw an example of, I think, house price prediction, and then we looked at how we can build a model uh, there with the help of scikit-learn. And then once we have built a model, we could save those models. And then after saving the model, we saw how we can containerize the model. And after containerizing the model, we saw how we can deploy it on top of Kubernetes. And while building these models, we need to do evaluation of different parameters or different settings. That is where we explored MLflow. So MLflow helped us how we can track the model in different configurations. So that is what we have been covering so far. And then we also saw how we can deploy the model with the help of Kserve. So in a way, we kind of covered how to create a model, deploy the model. But then there is one more thing which is a part of the entire flow is that how we can build a data pipeline and how that pipeline, what is this pipeline is all about, and why we should be bothering about it, right? Uh, so and that is what this chapter is all about. So once we kind of cover that part as well, that what is these data pipelines and how or why they make a lot of difference or why they are useful or why they're important in the entire machine learning journey. So once we cover that as well, I think it's kind of finished the entire cycle what we're looking for. But of course, if there is any other topic left, we'll try to cover that as well, right? So now data pipeline in a simple terms, right? That you may basically build a model once. So think about today you had data set of let's say 1 month, right? So you are building a model from the data set of last whatever, let's say last 3 months, right? Let's say um, March, April, May, right? Now June is going on. So you have built a model based on last 3 months of data set and that model is in live, correct? And it's working perfectly fine. But then now once June gets over, you may want to also add the June's data into the training set and then recreate the model and then serve it, correct? Now, of course, as we know that when we are building our models, we need to do some data processing in the beginning, right? So we saw that entire life cycle of the data or entire machine learning, right? In the initial step, we cannot do a data cleanup, data manage, data whatever, cleaning up, evaluation on all that stuff. Then we kind of feed to a model, right? But as we are going to add the June's data to our model learning process, correct? Do we want to do it manually, right? Because we built the model once. Do we want to really do all the stuff manually again and again, right? Every month we want to make the model, or there should be automation, correct? So how we can do that, right? So how we can have a process by which I can create a pipeline. So for example, when I input a new month's data, automatically data get cleaned up, data get formatted and all that stuff. Then of course we would create our model and deploy it. And that is what the entire thing we can do with the help of this data pipeline, right? And if you look at more examples, it can be data from your streaming thing, data from your social media. So there can be a number of ways where from where these data can be collected. And once the data has come up, we would perform, let's say, three different or let's say four different operations, right? We merge two tables, right? Let's say we get data, some data from our database, some data we are getting from our static configuration, or some data is there coming from social media. I eventually want to kind of merge them. That's a step, right? And then once I have done that, I want to perform some analysis or some cleanup of that and then take it to the next level. So you don't want to kind of do all of these things manually. And that is where we can take this help of Spark and the Airflow. So these tools are going to help us build these data pipelines. So just out of curiosity, anybody here in the call has built any of these pipelines before? Data pipelines in any form? Anybody has built? Oh, okay. No
No,
worries.
no.
Fine. So, yeah, so considering that, I was kind of trying to look at some basic examples, which I could not, but I believe in the next session I would bring it. But being said that, let's try to understand what are the how the things are happening as given in the book, right? So, now, if you know about Spark a bit, with the help of Spark, of course, the Spark would make sense if we have the large data sets, for example, in terabytes and petabytes, which we cannot fit in a single machine. So what we can do is we can share our data to, let's say, think about a very simple thing, right? Let's say you want to find out how much time a given word has come in the entire data set what you have, correct? Now, one way to do it is you load and then data into a memory and then do a counting of that number of words, how many times they have come. But of course, if the data is so huge, you cannot do it on a single machine, right? You would want to distribute it, right? You want to have multiple instances of some work running. So let's say if I fed 1 terabyte of data, it would get divided into multiple sub work, and it would be then given to multiple different machines or multiple different nodes. From there, we do the counting. Let's say from worker one, we got information that okay, the number or the for Kubernetes has been used 1,000 times. Then the other worker would say, I have counted Kubernetes 5,000 times. So we will eventually merge that stuff and tell, okay, Kubernetes word has come by doing the addition of all the output from a different workers, right? So we can kind of uh, divide our work to the multiple workers. Workers would do the specific thing and come back to us, right? That's something which we can do with the help of these Spark jobs. Again, Spark has more than this, just like it can manage data frames, it can manage streaming, it can manage some machine learning stuff, and it can manage graphs and other stuff there. So the idea is simple that okay, you divide your work, give it to somebody, and they come back to it. So let's say if we kind of look at the Spark website itself. Why it is going there? 1 minute, yeah. Apache Spark. Yeah. So as the name says that it is unified engine for large scale data analytics, right? So let's see. So I'll just try to do quickly. Okay, so that's a word about. We already saw that. What is it about the Spark jobs, which is a kind of a say a data engine, right? For which would basically give us analytics on top of it, right? Whatever you want to do. So we want to yeah, so that's one part. And second is how do we basically automate the processes, right? So, for example, we saw that, right? If we have got some CSV file, after getting CSV file, let's say we want to remove one column from it and transform one column to another column, or try to get merge data from uh, different source and come and bring it together. So we need kind of a say like a sequential job, right? So our pipeline would go over different stages, right? And how we would do that? That is what we can do with the help of the Airflow, right? So I've configured this Airflow and that Spark locally on the setup, but as I'm not completely confident, but today, but of course we'll kind of try to look at in detail later. But I'll quickly give you the UI of it so that it makes sense to you what I'm trying to convey here, so that at least we get more context today, so that all of you can also go and try it out. This is a UI the for the Airflow, and then I have one more endpoint. I believe 8,000. Yeah. This is the endpoint for my Spark thing. Now the Spark work in terms of master and you can say workers, right? So we configure a master and we can have this master work as a worker, or we can create additional workers. And then from the Apache, whatever the Airflow, we can basically shoot the workload which can be given to these Spark executors, which can perform something and give back to me, right? So what I have done is, again, this is an example from a Git repo from this person. But just to quickly take a look, what you see here is, I'll quickly bring this one up here. Let's see if I can get a different one here. Okay, so what you see on the screen is a Airflow. With this Airflow, we can create these um, DAGs, which is direct acyclic graph. So basically, we can build our entire data pipeline through this Airflow, and then Airflow can basically go and trigger the stuff through Spark and through other means as well, and try to build the entire pipeline with us. So we have configured this Airflow and we have configured this Spark. So what happens is, as I'm going to kind of run this particular, again, this may not work right now, but at least I'll show you. Or let me see if there is a good one, right? Yeah. If you look at here, what we have here is, what we are doing is we are, let me take a look here. Yeah, let's look at the code here. Okay. So this is how a DAG looks like, which is you are saying that, okay, what are the steps I want to perform to get my data for my whatever job I'm going to do eventually, right? So what we are doing here is, we are creating this flow. That's what the name Airflow is there, right? We are saying that start from some basic state where you are giving like what is the DAG I'm building, who's the owner of it, and all that stuff. Then we are defining the start and the end state, right? And we are simply saying that job started, job closed. But here is the important thing: we are trying to create the um, the in between, whatever data pipeline stuff you want to have. Like in this case, we are saying, uh, get the value of pi, right? So what I have here is, let me get quickly show in the terminal as well. I'll bring it here, right? Yeah. So here is my job, Python. So you can see that, okay, this is a pi one. So I can see that this is a pi, what do you call, say, a way to generate the value of pi, right? So what I want to do is I want to send this work to my Spark client or Spark master, and that would eventually somehow do the calculation, give the result back to me. So think about again like the way we have in Kubernetes, we have API server and we have these different worker nodes and so on, right? Similarly here, I have sent my request to the Airflow saying that, okay, hey, get me the value of pi. Now the Airflow is going to communicate via the connections. If I look at this particular configuration here, I can make different kind of connections here in my Airflow, and one of the connection was the Spark connection, right? So I'm saying that go and connect to my Spark endpoint and run this job there and bring the result back to me, correct? Similar to this, I can also add other things as well. So you can see here there are different connection types are available here, right? Azure, AWS, and so many other stuff is there. Data lakes, right? FTP, email, and other stuff, right? So what I can do is I can create this pipeline through the Airflow and offload my work, which would basically perform the stuff, get the result back to me, and I can go step by step. So let's try to look at some Airflow DAG examples. I'm just going on the fly right now. DAG examples, which would I think help you out. DAG examples, yeah. So maybe let's look at some images. So you can see something like this here, right? So let's see which we can understand better. It's a simple false, true, and all that stuff. Let's see this one. Let's see. I'm just trying to go at random right now, but let's see some example of DAGs, which would I think help us there, right? So data dynamic task mapping, external task sensor, maybe. Okay. I don't think so. We can let's have a look at some of other pictures here. Yeah, I think this kind of does it in a simplistic way. So you can kind of build this workflow. So if any of you have used na10 or if you have used Zapier kind of a thing, right? You know that you can build your flow, right? That okay, if the email comes, do something, then go to the next step and so on. Similarly here in our data pipelining concept, we can do these things, right? That okay, if this happens, do this thing and then perform. Like here, it is same thing, then join eventually if we have two steps then. Yeah, go ahead. What question do you have? Such a thing.
Was, does this run like automatically or does it run based on
Yeah,
event?
very good point. Very good point. Yeah. So I'll literally go to that particular flow which I was telling you earlier. So if you look at not here, so if I look at the DAGs now, so I can like the way we provision our uh, hmm, Spark. Yeah. So here you can define a scheduling interval as well, right? Like when you want to set up, right? So you can have days, months, whatever. So typically you can set up when do you want to, sorry, when do you want to schedule it. So there are multiple ways by which you can put up a schedule for this. And I believe this can also run on an event as well, that when something event happens, it will do something. So I'm pretty sure that I'm not fully confident, but it would be in that done in that phase as well. Yeah, very good question. Anything else? Yes, again, I'm also new, so I'm just trying to kind of share whatever I could. Yeah, but yeah. Okay,
Yes, I have another question.
please go ahead.
Should we always send the workload to Spark,
No,
uh,
that's the
or
whole.
Airflow can do it by himself, by
No,
itself?
no. So you can configure, right? That is what the whole idea about that these things, right? Connection types, correct? So, and then there is a concept of providers as well. Yeah, so you can see here that different providers are also available, right? So, with the help of these providers, we can connect to any endpoint. So, for example, if I want to talk to the MySQL, right, I can do that, correct, and get the data and then do something on top of it. So, Spark is one of the provider or one of the way to connect, right? But it can do more than that. Right? So as you can see, it's a plug and play operator, what was mentioned there, right? So it's a platform created by computer to programmatically author, schedule, and monitor workflows. So let's look at um, some use cases here. Um, yeah, so if you look at in terms of ETL, right? Providers. So it has many providers, and based on the providers, you can do many different things. So it's not limited by only the Spark. So Airflow in general is any workflow. So any workflow means anything you can build. Like if I let's see, uh, there should be some examples here. Yeah, like for example, per customer, right? Simple workflow can be, so for a given customer, we want to have a different kind of a report, right? So you can build the workflow for that, right? So now you don't want, let's say, whenever a request comes from a given customer and you want to give them a custom reporting, right? And to build that report, you may want to fetch the data from a database. Want to fetch the database. You want to fetch the data from your your maybe log something or whatever, right? So all of these things can be done. So we can build the entire flow based on the requirement, and the pipeline would run as you would run it manually, or you can do it on a given on a given schedule, right? So it's not related to only Spark. It's a generic workflow management system which can do many different things by talking to different endpoints and what was those endpoints which was mentioned earlier. So let's just see that Docker stack. Yeah, provider, right? So these are providers, right? The different providers are there. So as you can see that you can build the workflow with Discord, with Docker, Elasticsearch. So you can build any workflow. For example, simple thing, right? Let's say, let's say, um, let's say kind of let's say something happens in a platform, an environment, right? A database, or let's maybe think about, let's say Docker one, that may be a simplest one. So connection type Python API talks decoder. Let's think about, let's say if example tag. Let's look at here actually. Example docker.py, right? So what we are doing here is we are building a kind of a say a workflow. So what we are doing is we are going to when we build our when we build our workflow, right? Now as you can see, there is no Spark here. The operator is Docker here, correct? So now, as we are doing in this case, we are saying that, okay, this is a simple DAG test for Docker one. And let's see what it's doing here. So we are saying that, okay, bash operator, print date, operator T1, T2, T3. Okay, so connect to my Docker daemon, right? That's what it's doing here, right? So we are saying, so T1, T2, T3 are our, so this T1, T2 built on the bash operator. So again, there's a built-in bash operator through which we can send a command, for example, right? Then T3 is a Docker operator. And now what we are doing in this case is, in this case, we are saying T4 is the bash operator, which basically print hello world, right? And then we are saying run this particular thing in a given order. So T1, first T1 would run, which would say date, will print date. Then T2 and T3 would run. I think maybe it will run parallel. And then we have T4, which is going to give us this thing. Let's just try this out again on the fly. I'm just trying it out. So it may not work, but let's just give it a shot, right? So what we are doing is we are copying this wget command will not be there. Let's just copy it here exactly as it is, right? Now what we can do is we can put this DAG into this folder here, right? So I would say docker flow.tag. No, it's not .py, right? .py, right? So I mentioned this particular DAG here. And now what should happen is automatically this particular DAG should be available in my environment here. Not really. Something else need to be done as well. It is in this folder itself. So do I need to reload or something? Let's see. Tags. Is there any way to add a new tag? Hmm. Hmm. Okay. Let's see. I mean, we need to reset it, but I don't know how to do it. I'm just going to quickly do this docker compose down. And hopefully this should read after that. And we'll see how we can add a new DAG in our setup. So I've set up this particular repo, which I can give the link to. But for now, let's just do that. It takes some time to come up. Uh, Oops. Same port number, right? Or something happened here. Okay. Okay, it should come up now. Unicorn starting. Oops. I just wait. I think wait a few minutes. No, it is still not there. So jag import. Some error has come. Okay. So something is wrong there in this case. So that is good. So at least we got something is there. So let's see if we can check that. So what is it? Okay. Test will import get test one. What is it? Okay. So where is the test one? Okay. Okay, something is wrong here, I believe. Yeah, I think that this kind of not required. Just comment it out. I don't know whether that's going to work. Okay, let's just look at if we can get some other example from there. Sorry about that, but yeah, we're all trying out. So end of operator. Okay, let's quickly try if that works. Otherwise, we'll just not waste our time anymore. Let's just try and comment this. That should work. Yeah, it is there available as you can see. So now what I'll do is if I look at the graph, it tells me that what is happening here and I can execute it now from here. So let's see what's happening. So this is, as you can see, this kind of failed because it may not be able to connect to my Docker daemon per se. Because in our Docker daemon, we are saying that, okay, perform that Docker exec. So our Docker, this is running on a container itself, so it cannot connect. But what we can do here is, let's see if we try something else. Okay, but hope you got the idea, right? What's happening? Any questions? That if somehow we could connect to our Docker daemon, then it would work. Does it make sense? Okay. Yep. No. Any questions, guys?
So yes, I got just general use cases.
Huh.
I seem to remember in my work we were using Spark and Hadoop collecting measurement data from cell sites. Terabytes of data, measurement data on
Mhm.
cell site performance and mobile networks.
Mhm.
So we were using something like this.
Mhm.
And so it was huge, big data kind of, I'll call it stream processing for lack of a more precise term.
Mhm.
Looking for anomalies, anomaly detection, and places where potential dead spots were happening in mobile networks. Okay, so
Mhm.
that's the application. What are other applications for this? I just don't, I have data that I process that I just get a cron job out and I run a cron job. And the data isn't so big that I can't just, it's it's a Kubernetes cron job, just using the job constructor. When would I use this? What are the trigger points for using this? Because this is very powerful, but
Mhm.
I can do simpler, same thing with much simpler constructs. So thus I'm trying to learn. I'm trying to learn where the use
Yeah.
cases kick in.
Okay, so what I have seen, look at the use case of these kind of a thing, right? Like, let's say, let's go back to this MLOps stuff, right? Maybe that may kind of try to connect the dots there, right? Um, so, uh,
Airflow. Airflow is new to me. Yeah, yeah.
yeah, so extensively down Airflow features of monitoring, alerting features to the Airflow providers. Okay, so it is a generic workflow provider, and then you can do it for purpose like um, mm, like for example, when you are doing you said about stream processing itself, right? So whenever a data is coming, so if you want to do a real-time prediction, right? So you need to stream the data. Let's say you can use Kafka and Airflow together, right? So you can get the data from the Kafka, and then you can give it to Airflow, and then it can perform some analytics on top of it, and then take it to the next level and so on. Right? So it's a generic workflow engine. So as you can see, with the help of these provider itself, that tells you on what all things you can work with, right? So if you look at the providers here. These providers are endless, I believe, right? You can see Slack, Telegram. Think about if you want to send a message, right? Again, um, um, so, so let's take an example. Let's say in your Kubernetes cluster, somebody removes the pod, and as somebody removes the pod, we want to kind of send something to the setup, right? To the Slack channel or to your things, right? So you can, I believe, build all of these things. I mean, this kind of going way too forward, but we can think of those. Let's look at some use cases. Let's just regular search, which can help us understanding Airflow. Use cases, right? So let's look at right ETL pipelines. Um, yeah.
Okay,
So
so just a question. So I use Camunda
commander,
as a orchestrator.
commander is how to spell it.
Kamunda. And maybe it's old, or maybe it's old school, or maybe it's not
Is
Kubernetes or
this
something, but
one?
it's just, yeah.
Okay. See. Okay. Yeah. So it's also perfectly.
And
Yeah.
so is this just a better Camunda?
Maybe you can say like that. Yes. Maybe. Yeah.
Okay.
It may be better, and then maybe have more integrations, and then for data, at least MLflow for the machine learning and all that stuff, right? It is used for
Yeah.
that purpose. So what are the things they can do? Organize microservices, APIs, RPA, legacy
Yeah, okay, yeah.
insurance,
Okay,
yeah,
okay, okay. So
something
now
like that.
with that background, I'll go do some homework.
Yeah,
With that background, I'll go some
yeah.
more. Okay, so this is
Okay.
maybe a better Camunda, or maybe one's old, one's new, or one's
Yeah.
for real time and one's for back office provisioning or something. I don't, okay, okay,
Yes. Yes.
okay,
Yes. Right. Right.
okay.
Okay. Any other questions? Okay, so with that, let's try to understand how they are trying to use in the book. So that kind of give us one circle of it, and then we can see. Okay, so now with respect to this book, what we kind of need in a way. So again, as we are talking about this book in which we are doing a machine learning, right? Now, what we would want to do is, as we are building any of our notebooks, right? So as we know that we have seen that when a kind of a developer comes, he would try to create a Jupyter notebook, and that notebook the user would perform certain operations and so on. And then what we can do further with this Jupyter notebooks, as we are deploying on Kubernetes, we can put certain configuration. So that Jupyter notebook can come up with certain configuration, like I want to um, I want to run my Jupyter notebook with the GPU instance behind the scene. Similarly, what we can do is, as we are building our Jupyter notebook, we can also attach a Spark um, instance to it, right? So that may come as a built-in part of it. So we can build these intelligent notebooks, which basically comes with all of the things which I would need as a part of my process, correct? So now, considering that in mind, um, what we can do is, in the case of Kubernetes, right, we can configure these Spark cluster. So Spark, as we discussed, it works in the master and workers. So what we can do is we can configure an Spark operator on Kubernetes, which we discussed in our previous books, right? That operator is something which is like so we deploy an operator, we kind of create our own object type, and that object type, as we trigger, our given instance get created. So for example, in this case, I would configure a Spark master or a Spark cluster object as a part of my Kubernetes cluster. Now, when I'm deploying my Jupyter notebooks or my work or my Jupyter notebook, I can create a Spark instance. So I would create a Spark instance for doing my own work itself. So it's like that. As a developer, when I log in to the Jupyter notebook given by my setup, that notebook would have a functionality to trigger a Spark cluster on its own whenever is needed. Correct? That is what we are enabling in the case of our environment, that we would deploy a Spark cluster operator, and that operator can create Spark nodes or the Spark environment on the fly. That's something which we can configure on the Kubernetes setup, that we have that operator, and then as per the need, we can create these Spark clusters whenever there's a requirement what we have that we can set up. Now, in this case, what is happening is we have an example of a flight data set. So this data set of flight is available to us from the Kaggle. That's the example what they have taken. So the use case they are saying is there is a website which helps you buy tickets, right? Now, as a end user, if I go and try to buy the ticket, and if I buy the ticket, and what I realize that the flight which I booked is delayed when I actually flown there, right? Like it took some time. So what I want is I want to give my customers. If I am a company who is selling tickets, I want to also tell when my customer comes and trying to buy the ticket, saying that, hey, this flight has been delayed more than so much of time in the last 1 month, right? Or last 2 months, right? Or this particular flight always goes on time. So when I'm going to book my flight, I know that, okay, if I book this particular flight may end up on the right time as per my requirement, right? So now, to build this kind of mechanism on my website, I want to have some kind of machine learning things, uh, kind of thing built in my environment, right? So that I can predict, right? That when somebody is trying to book a ticket from this place, I can tell, okay, these are the options you have, and let's say Delta flight is going to be on time, but let's say American whatever other flight is going to be delayed for some time. So I want to kind of build that kind of mechanism, right? Now, what I have here is I have flight data, which is coming from me, which I have in my database, right? And then I have the information of all of my um, airport data set in another file, right? So as you know that flight is going to be flying through, or let's say if I'm using the flight IDs, right? I'm using the flight IDs to track the flight. This is a flight number. This goes from this place to this place. But then I have a data set which contains the flight number and the destination, or the what do you call, say, some kind of mapping between the code of the destination and the source, along with their name. So I have these two different data sets. One which is giving me all the flight information, one data set which is giving me the name of the given airport, right? And I want to merge them as we kind of go and do our analysis. That's some example what they have taken something similar. So what they're doing is, we are putting our data set into the S3 bucket, right? And then what we're doing is, we have configured a Jupyter notebook which has the connection with the Spark already built into it. So as I trigger this Jupyter notebook, I can actually perform my Spark operations into it, right? Because as I run my um, as I run my Jupyter notebook, I want to make sure that whatever work I am doing, it should be done through Spark, because I would get the faster result from it. So I will configure that particular part here. And now what's happening in this case is, as I trigger it, I'm going to connect. So now you are saying that I'm doing the connection with my database, which has some data there. I need to kind of go and check back there, which data is coming from there. So what we are doing is, we are trying to merge. We are trying to kind of get the data from that database, and then we are going to get yeah. So here, as you can see, what we are doing is, we are building this Spark job uh, through to get the data from our database, because the data which we are going to have from our flight data is going to be, it is like 100 million records, right? And 100 million records, I may not be able to read into my single instance, right? So what I want to do is, I want to kind of go and send it across, and then try to read via different sessions, and get it. So once I get my data via the Spark jobs, that is one thing I'm doing. And second thing is, here, database been accessed. Now, while the flight tables contain the flight information, we also have the airport and the air information in the CSV file hosted in the bucket. So now what we are trying to do here is, we are trying to make another Spark job, which can kind of go to the S3 bucket and get the information from there, which is the information about the airport and the airline number, whatever is there, right? So I want to get all of this data. So basically, as you can see, this is the flight table, this is the airport, this is the airline number, and all that stuff. So I want to merge all of them together to build actually my data set for my machine learning job. So you have to understand that to build any useful machine learning thing, we need to have the right data, right? If we don't have right data, we can't will our model would not be the right, correct? So for that purpose, we may need to collect the data from different places, merge them, and then we would try to do our machine learning on top of it. That is what is happening here. We have a flight data somewhere, we have information about our flight and the airport somewhere. We try to get the data together, and then eventually, once we kind of get it, we want to merge them, and then it will give us a data frame which contains the information about the airline number, as well as the whatever the code of that thing as well, right? So I'm trying to kind of somehow capture that, and once I have captured that, I have my data, which is in the right format, and through which I can, then on top of it, I can build a machine learning thing. Now, this is what we have done, as telling you, right? This is what we are doing for 1 month. Next month, I again want to get the same data and then use it for my training purpose for the last month, right? So this thing, what I have done manually right now, I would want to do it as a part of my um, automation, and that is where the Airflow would come into picture. That
Okay,
all
so,
of these,
and thus the use case. That's the use
yes,
case.
correct,
I'm gathering data every period of
yes,
time, and it doesn't have to be in notebook fashion. It can be in automated fashion,
yes.
and these tools help automate it. Okay.
That's the whole. So I built kind of a lot of story, but that's the whole idea that you did something right one time manually, but then next month you are not doing it manually. So I want to kind of
Mm-hmm.
add that thing as a part of the Airflow. That's where the Airflow would come into picture, and I would add all of these things into picture. That's it. As you can see here, this is what is being added, right? Start the Spark cluster, right? Then merge the data set, right? Clean the data set, then stop the Spark cluster, correct? So this is my DAG in this case, right? Which is I'm going to use as a part of Airflow,
Okay.
correct?
Yep.
That is how the overall things are working. So I'll try to. I thought of I would want to create, but I could not. So I'll try to give some more time to it, and hopefully I can bring up a demo of this. And then once our data set is there with us, we can now then build our model, or basically, as you know that, right? Uh, Model need to be rebuilt again for the new data set what we are doing. That all of this has to be automated, right? So then once data set is there, we can read in our model, and then we can again send it to a MLflow, which will have a different version to it, which we can deploy with the help of Kubernetes or Docker, whatever we are doing. Okay, so there was some on the chat. I did not see it earlier. Let me just check what is there on the chat. Okay, I think that's the time what we have. So hopefully, we would try to finish it off tomorrow, at least this particular part, and that kind of um, see my kind of technically would finish, but we'll see what is left after that. Yeah. Okay, that's all from my side. Any questions you have?
No, I'm good. Thank you for the information. I learned
Okay,
something new every Thursday.
great, great. Okay, see you guys. Thank you. Bye bye.
Okay, bye-bye.